Hi everybody, welcome.
Hello.
This presentation shares real-world experience from successfully achieving SOC 2 Type 2 compliance and HITRUST certification at Encore Healthcare, the company I work at. This is not going to be a checklist of this is how you pass. It's going to be focused on what you can do to make the audit go much easier than it did for us, because we were not prepared. I'm Matthew Connerton. I'm the VP of Software Development and Engineering at Encore, and I've been playing with Drupal for about 17-ish years now, around the Drupal 5 days. And Encore Healthcare, our company, is a software developer and population health company focused on providing better outcomes for patients with COPD and chronic respiratory diseases while reducing healthcare costs and increasing the quality of life for those patients. So the scope and context of our security compliance, we are a SaaS application. We host in AWS. There was a lot of overlap in SOC 2 Type 2 and HITRUST. We actually were finishing SOC 2 Type 2 while we were starting HITRUST. And the focus of what we're going to talk about in this session is the engineering side of things. Just a couple of definitions, if you are not aware of them. PII is personally identifier information, anything that could personally identify you, that I could figure out who you are. And then PHI is protected health information. That's a subset of PII, and it is far stricterly controlled information. There's heavier penalties if the PHI is released. And then our Nexus application, just for some context here, it's a multi-tenant SaaS application hosted on AWS. We have a front end using CloudFront and Lambda and S3. Our back end is a typical Drupal site, EC2, RDS, S3 for the file private system. And then we use the sprinkle of all those other AWS services like Route 53 for DNS and VPC for our private network, et cetera, et cetera. So the most important part of security compliance is documentation. Absolutely everything needs to be documented. If you just document your stuff, that's 60 plus controls in the system that covers, that are covered by documentation. It just really solves a lot of the preparedness that you need to have. Without proper documentation, you can't prove the controls are operating effectively, regardless of how secure you actually are. All decisions and changes require documented approval. Even if you have controls that are maybe not quite up to par, if you're documenting why you're not quite there yet and what you're doing to mitigate that, you can still pass those controls because you've documented it. There's a reason why. You want to store your documentation somewhere. It doesn't have to be big and fancy. Google Docs, Wiki, Confluence for your documentation type stuff. Pretty much any project management tool will suffice for your task type stuff. An Excel file with all your tasks in it counts as documentation as long as it is stored in a versionable, protected area. Just pick a place and be consistent there. Stick it with it. We had to go hunt and find some documentation because some stuff was done in Google Drive, some stuff was done in Confluence, some stuff was done on some guy's computer. Find a place, be consistent with it. You can even document in your code base and use a static site generator to build it. So what exactly do we want to talk about? What exactly do we want to document? Well, the rest of this presentation is going to talk about the controls of compliance, and the gist is all that stuff we're about to talk about. The SDLC will talk about documenting things in tickets and for changes you need to make. You want to document SysOps and DevOps changes, any architecture decisions. You've got to document it. Just put it somewhere and say, this is what we want to do. This is one of those things you want to start as early as possible, build it into your culture, build it into how you work. Becoming compliant takes a long time, and we'll see some timelines later, but it took us 18 months from start to finish to be HITRUST compliant and get certified. If you're not, and that was already being SOC 2 Type 2 compliant. So if you are not compliant at all, if you don't have these practices, it can take 2+ years to be able to pass all of these controls. So start early. Policies and procedures are a great starting point. You want to start with templates. You just Google them and replace the fine details with what you're actually going to do. The key here is actually do what you say you're going to do. There are dozens of policies you will need to keep track of. This presentation will be available. I'm not going to go into detail in all of them, but just to very quickly scan through them, you'll need an information security policy, an incident response policy, IT asset management policies, information security management program, configuration standards, internal controls, security audit and accountability, business continuity and disaster recovery plans, business continuity plan, retention schedules, personal information security policy for termination or change of employment, information classification, access control policies, change management policies, use and return of company equipment policies, communication policies, system availability policies, technology acceptable use policies, employee breach policies, a privacy policy, a new hire policy, that's in there double, a third-party agreement, and a password policy.
Who wrote all those policies?
We did. We started with templates, and we went through them, and we filled in the gaps. Part of what I'll get to later is it's going to be very hard to do this alone. Find a consultant. They're worth the money. They help you with all of this stuff. Our consultant is the people that gave us our templates. But you can just as easily, if you really want to get a head start, if you're not ready for it, just Google these policies and go for it. Again, the key is whatever the policy says, that's what you really should be doing. So you have these policies. Let's go through some of the different types of controls. A big one is logging. A lot of the audits requests that you're going to get are to prove, we're following these policies, and a lot of that is going to be found in the logs. Context is very important when it comes to our logs, especially for us, we're a multi-tenancy application, so when something happens, I need to tie that to the account and organization, the user identity and their roles. We add in special trace IDs so we can correlate different logs together if it's happening through a chain of events or through queues. For compliance, you really can't overlog. The more complex, the better. The more context is better. Obviously, this is going to generate a lot of data. Where do you store it? If you're just starting out, dblog. Maybe from there you start using the file system. That's what we did. We used Monolog to dump our logs to JSON files, and then we just sync them up to S3 on rotation. Eventually, you can start aggregating those logs centrally into something like OpenSearch. That's super cheap on AWS. Or you can use one of the many viable logging platforms. Some are paid, some are open source. We use Datadog because they offer a lot of other services that fall under the umbrella of compliance. But we used New Relic for a while before we switched over to Datadog. There's services out there that strictly just do logging. You can really just pick one and have at it. I mentioned Monolog. That's a library that abstracts out where logs come from and where do they go. So you can pick and choose your channels. You can say you want your PHP logs to go to this destination. You want your application logs to go to that destination. Everything else can be dumped to the standard output. Log retention. You have to keep your logs for a specific period of time. It depends on the security framework that you're using, how long you need to. For SOC 2 Type 2, it was a year. For anything with PHI in it, it is going to be 6 years. So you need to make sure you're set up with your backups, we'll talk about later, so that you're not actually losing any of this log information. What are you going to log? For the Drupal side of things, we log the standard Drupal stuff that you would get out of the box. In addition to that, anytime configuration changes, whether automatically through deployment or manually because somebody did it and they weren't supposed to, that gets logged. Any of our custom code that's doing automatic jobs, background processes, we add as much logging into the system. We integrate with a lot of APIs, so we add as much logging as possible. So if anything goes wrong, is breaking, that can be elevated to us as quickly as possible. Anything security related, you want to log. We use revisions of our entities as a type of log. On AWS, we just basically have everything turned on. CloudWatch is aggregating it all together. CloudTrails is logging the accounts, the users who are using AWS. And GuardDuty is making sure that we don't do anything sketchy. It is setting up our anomalous detection. If it sees that I'm making a bunch of weird API calls, it will throw out notifications to people. You can log things that are not exactly logs, but are still something that can be auditable. We have some custom entities that integrate with our system. One's an activity entity that records right now, pretty simple, when a clinician is downloading a report. We log what report it was, when they did it. That also helps us keep track of if anything in the report changes. We can let that user know there's a new version of the report. With our integrations with third parties, we're working on a sync window entity that records compliance data. We fetch device data for ventilators, and we get that data every single day for all of these devices. And so we have a compliance a sync window that will keep track of the month or the day or whatever the period is, if we were able to get it for that particular integration. If there were any exceptions, any problems, we can dig into it. All of these logs can then be used to generate alerts and intrusion detection. Part of the context you want to make sure all your logs have is, was it triggered by a user, and was that user an administrator? We have separate logs and views set up to see what exactly our administrator is doing. And if anything hinky is happening, we have alerts that can fire for that. Ideally, you want automated detection rules for those anomalies. Datadog is pretty cool because they're starting to bake some of the AI stuff into that. Well, they can say, well, I don't know what Drupal is or what your stuff is, but you have something weird going on here that wasn't going on, for the last 3 days. Evidence we provide for this, when they ask for it, is going to be our CloudTrail logs, application logs, lots of screenshots of our different policies, screenshots of our configurations, to make sure that we are set up, we are making sure that we get alerted if something weird happens. Onboarding users to your company has a lot of compliance implications to it. You need to document it. Have a JIRA ticket or whatever your project management system ticket is. Have a template with a checklist of everything you need to do. Make sure it's owned by somebody. Make sure it's approved by somebody else. Track completion as you go. Account access and provisioning, single sign-on with one of the big providers is a fantastic source of compliance because you just offload all of that to them. You don't have to worry about setting up multi-factor authentication or password reset emails or any of that. They take care of it and you inherit it. You want to require least privilege for your users. Make sure you're setting up role-based permissions, no matter where it is, whether it's your Drupal site, whether it's in Google. Everybody should have that least privileged set of role-based access. Nobody should just get access to production or PHI by default just because they're a developer that comes on board or whatever. That should only be given out when and if it's needed. We have a lot of break glass accounts. I say a lot. We have an AWS break glass account and a Drupal one, which is technically our admin user. But in the event of an emergency, I'm hit by a bus, the other senior dev is hit by a bus, Nobody else can get into AWS. Our COO has a method to be able to get into AWS with our access. By default, she doesn't even have access to our production environments, but she does have a method to get that access when needed, so it can be handed on to someone else. Your users will have legal and compliance requirements, background checks if applicable, NDAs, confidentiality agreements. The auditors are going to want to see all of this happened. Policy acknowledgements. Your users need to acknowledge the policies that you defined earlier. That usually goes in line when they acknowledge your employee handbook. HIPAA and security, privacy trainings, all of those, if they are required, which for a lot of these compliance frameworks are required for you users, you need to document that they took that training that was made in 1996 and is ridiculous, but apparently it still counts. Security awareness training, PHI training, social engineering and phishing training. The engineering team is pretty good, but our company, is 80% respiratory therapists or nurses or clinicians, and they're not going to have that high level of awareness that we as engineers will have. So they all get training, and they have to go through that training periodically. Tool-specific training, that's not a strict requirement, but it's occasionally something that they asked us if we did it, and we said no, and they said whatever. Device and workspace setup. If it's in your scope, then you need to make sure that your devices are set up. The scope of our compliance was really our Nexus application, but it did also include our Google and Windows accounts because they drive our devices and our devices ourselves. Since we're the developers working on it, we push the code, so the devices need to do it. And our clinicians are accessing this PHI information through our application, so those devices were in scope as well. Have a system to manage and own all of those devices. All the big companies have them. We use Microsoft Azure and their endpoint management, so it's all controlled remotely. The evidence we give for that are the screenshots of the policies we have there that says, the end user is not allowed to do this and not allowed to do that. Even our dev machines are a bit locked down more than we want to, and we're trying to work on that. But password manager setups, enforce MFA, disable USB. Our laptops, USBs are disabled. We can't use USB drives or anything like that. They don't want us to download patient data and bring it somewhere. Can't disable Control P, although. Evidence we keep is everything we talked about. Since we have JIRA tickets and a checklist, every time a thing gets done, a check goes on the box, the evidence gets applied to the ticket. And so when they say the auditors sample our new hires within the period and say, I want to see the onboarding for Jeff, we can say, oh, here's Jeff's ticket, and just do a screenshot, export of that ticket, which has all of the steps and timestamps and handing off of what happened. Offboarding, do everything you just did but backwards. Make sure you disable all the accounts. Again, this is where SSO can shine. If they have to have SSO with MFA to access your stuff, when you disable their SSO, they can't access your stuff anymore. Revoke their prod access, remove them from groups, wipe their devices, rotate any credentials or tokens that they might have had access to, remove them from the password vaults again. If they were added through SSO, that's not a rush. Update on-call schedules, stuff like that. Again, we have a ticket and process where all of that's tracked in JIRA, and as it gets done, we check it off in the ticket, and that is our evidence. Access control. Access control is access to our site, access to AWS, access to the servers. In some cases, if you have a server in your office and that's in scope, access to the office. Access control policies are going to cover all of that. The gist, least privilege, role-based access control needs to be enforced, multi-factor for everything, SSO where possible. It really does shine. It really isn't that expensive, especially for smaller organizations. If you can get started early, it's just another thing checked off the box that you don't need to do later. For things like multi-tenant applications, we're using the groups module. We're about to be using the groups module for tenant scoped access to areas on the platform. Admin accounts, HITRUST, specifically required separate administrator accounts if we needed to elevate admin permissions. So in Azure, I have my regular mconnerton account, and then I have an mconnerton.admin account if I ever need elevated Windows permissions, because they want that scoped separately so it can be audited separately and easily. When it comes to your apps and your servers, deny everything by default for your ingress and outgress, outgress, I like that. HITRUST specifically did not allow any of the allow all rules that you'll get out of the box with your firewalls. Private VPC for anything that's sensitive. All of our servers are on a private network, and then we just poke holes through it through the load balancer or whatever needs access to it that way. Restrict server access to secure entry point server. That's what I just said. We use Tailscale for SSH access. That's the only way you can access our servers on the VPC, and it's way cheaper than using AWS's VPN, and it is authenticated through Google, our Google company accounts. So again, that's another place where if Matt goes crazy and we need to let him go, we just have to disable his Google account and he can no longer access any of our stuff because all of that is authenticated through that system. Network and perimeter controls. The firewall, just have firewalls. Make sure you explicitly define what is allowed to go in and out. Block everything by default. Only require the ports and protocols that you need. Make sure everything is being moved encrypted, no plain text traffic. Segment all your prod and non-prod stuff. And again, document it. You have to document all of this, and we'll see ways to do that specifically with this later. You really want a web application firewall. Protects against the most common stuff that are out there. Cloudflare is a web application firewall. CloudFront is the one that we use that's built into that. Every major hosting platform that you have is going to have a WAF in one form or another. Definitely use it. I think nowadays, if there's big Drupal critical issues, these major web application firewalls have the hotfixes built into them before they're publicly released, so that if you're using them, you're automatically mitigated. You still have to patch your stuff, but they can detect if the user is trying to exploit some issue that has been released. So you have all of this access control policy, you have all of this access that you've granted out, you have to review that. And actually, these reviews are something you'll see common across all your procedures and policies. You need to review them quarterly, yearly, however often. I think we do access reviews twice a year, and that is we go through essentially everybody in the company. What do they have access to? What access has changed since we have to document everything? All we have to do is query for all the tickets that were for access control, and we know everything that changed, and we update the wiki page we have for that as we go. We can have discussions on does Jeff really need access to the prod server? When was the last time he needed to shell into that? Remove anything, if people let go or left or people added, update the central documentation that way. Evidence we provide for this is the policy, lots of screenshots of our configs. Part of access control is a good password policy being enforced in your different systems. In AWS, we enforce it. In IAM, in Drupal, we enforce it with the password policy module. Make sure everything is MFA enabled. We show screenshots showing that in AWS. And in Drupal, they want to have a privileged user list because they're going to sample that list and say, okay, now prove specifically for these people that they have all this stuff enabled. Our access review logs, when we have those meetings, our configurations for our firewalls, our AWS security groups, and our web application firewall config. Next up is our SDLC, that is the software development lifecycle. We typically like to move fast and break things and have that velocity. That's not a great thing to do when you're dealing with PHI. So we try and go a little slower as we go. As with everything else, it starts with documentation. Here is where you get a bit of overhead. Every JIRA ticket we have at the epic level and the story level needs to have a business and security impact documented into that. We need to know the context and background of whatever it is we want to do. Why does the business need this? Are there any regulatory or contractual drivers? What are the actual business requirements? What's the security impact of this thing we want to do? What's the risk if we don't do it? What's the privacy impact? Does it involve PII or PHI? Is there a way we can minimize the data exposure or considerations? Are there any regulatory impacts with HIPAA, GDPR? What's the acceptance criteria? Are there dependencies or constraints with anything else we're doing? Is this going to impact any of the systems, teams, or vendors that we're partnered with? Are there any technical blockers or ways we need to sequence this? There's a lot we put into every ticket now because that is what is expected. That's part of the controls. We have to say that we've thought about all of this stuff anytime we make a change to production.
You mentioned a number of times grabbing screenshots. Do those go into the tickets too, or where do you put this?
So that is when it comes time to give the audit, they'll say, this is everything you need to prove to us.
Right.
And we'll say, okay. And you have to take a screenshot. You have to have it include a real-time clock somewhere. So we just have the date on the windows in the bottom corner, and just at that time is where we take those screenshots. Anytime you have a release to production, you have to document it. We document it in 2 layers. Every individual change we make is a ticket that gets documented at the ticket level, at the code level with pull requests. And then the entire release itself is going to have a documented ticket of everything that's in it, who approves it, and that has its own PR as well. A big key here is the status change, going from step to step, from new to gathering requirements to analysis to ready for work. Having all of those steps defined and seeing them be passed from one person to another is very important. Any infrastructure changes, every change to the production infrastructure must be documented. If you want to add memcache, if you want to add a new server, if you need to open up a port, whatever, all of that needs a ticket, and it needs to be approved by someone. That's a lot of overhead. That's a lot of work. I'm not a PM. I hate being a PM. That's where AI comes in handy. This is a very easy way to leverage AI. I use it in 2 different ways. First, I use it to create a specification. If we're doing something new, I say, ask me questions, so we fully understand the issue and we build out a spec. And then I take that specification, bring it over to the other AI and say, generate boilerplate tickets. And I already give it instructions saying, these are all the things we need to think about, those couple of slides ago. Create me a JIRA ticket for this. And that gets me 90% of the way there. And I just go in and say, okay, great, I just got to clean this up now. We're not going to do that now. We're not going to, okay, yeah, we'll do this. It's really nice. It eliminates the overhead of needing to do that. And it gets you thinking about all of this stuff that we should just naturally be thinking about when it comes to security and compliance. It gets you thinking about things you might not have thought of. So this is how we are and we're able to actually do that level of detail with our small team and be able to pass these controls. We let AI do 90% of the work, and then we just fine-tune it in the end there. Now, for the most part, the majority of our tickets include this level of detail. Part of the SDLC, an extremely important part, is separation of duties. A developer is not allowed to create a ticket and create a branch and code some work and then QA it themselves, then UAT it themselves, then push it live themselves. That's absolutely not allowed. And that totally never happens. not another company, of course. There has to be someone else in that chain. That could include a separate developer that does code review of that ticket. It could include a product stakeholder that does the UAT for that ticket, and they say, yep, yeah, that does what we want, thank you. It could be a developer manager that is assigned to the release ticket when everything's ready to, the release is tagged, it's ready to go live, it gets assigned to them that says, hey, this is live, this is everything in it, here's the PR for the release. I guess that happened before it's tagged. Are we allowed to push this live? And they can look at it and go, yep, that looks good, push it live. So it's not that the developer literally can't do deployments, is that there has to be a break in the chain. Somebody else has to agree and say, yep, this can go live, this is approved to go live. Somebody else has looked at this code as well. Obviously, if you're a single developer, that's not something you can do right now, but also you're probably not becoming SOC 2 Type 2 compliant as a single developer immediately. A few more things under this. QA and UAT need to mirror your production environment as closely as possible. They were pretty strict about this one as well. The environments need to be as functionally close to the prod environment as possible. At a minimum, you need to be running the exact versions of the software. Our prod is all AWS stuff. All of our non-prod is actually DDEV hosted on a single server, but since we're matching the version numbers of our software, we're able to pass the controls. Automated tests and security scans are included in this. We'll talk about that in a bit. Tag and archived releases. This was an interesting one that we had to mitigate a little bit because we don't quite do this. HITRUST wanted us to have fully static deployments. They said production servers shouldn't have build tools on them. They shouldn't have, Composer, NPM, Git. None of that should be on your production server. You should be dumping an archive, extracting it, and then it should literally just be whatever the minimum amount of software is to run that particular bit of software. So we weren't quite there yet. We were working on it. They were happy with that. We had it documented out, what our new production servers were going to look like and where we were going with it. We had the user and permissions locked down, so it's not like the regular old user is allowed to use Git or Composer or anything on the prod server. So that was another mitigating factor as well. And we documented it, and that's what helped us pass it. Evidence we provided was the policy. They sampled for the period changes that we made to prod, and we gave them screenshots of everything. They really just wanted to see that the statuses were going from one person to the other, and one person was approving it, and the code review happened, and so forth and so forth. And then our configuration. Speaking of configuration, configuration management. And here we're primarily talking about infrastructure as code. The big one is compliance strongly prefers that you use infrastructure as code. They frown upon us going willy-nilly into the AWS console and clicking out like a new server, and I want to upgrade this server, and I want to do this. It'd be like if you went to your production Drupal site and said, okay, let's edit a new field and add a new field here and do that. It's kind of the same thing. So ideally, all of your infrastructure from the beginning, if you're doing something new, should be in code. There's dozens of tools you can use for this. Terraform, AWS CDK. We use something called sst.dev for the new stuff we have. But having your infrastructure in code is very preferred, helps with documentation, lets you follow those requirements with the SDLC, and you really need to always do it. Except there's going to be times when you can't do it. Our application, when I joined this company, was 7 years old at the time, and it had 7 years of AWS CRUD of 3 different groups of developers doing stuff in that console. So the legacy infrastructure can remain in not infrastructure as code as long as you are documenting the process of if you need to make changes, what is there, how you review things and change things. And that's what we did to be able to pass those controls. As we said, there's a strict process for us to go through. We have to open up a JIRA ticket. This person needs to approve it, et cetera, et cetera. Any new infrastructure you create really should be infrastructure as code from that point on. And that's what we've done. You want to code all of your DevOps. You're spinning up servers, you're spinning up resources, then you need to do stuff with them. This could just be some bash files. If you want to get fancy, it could be Ansible. But whatever it is, if you're running commands on those servers, all of that should be created and put into a code repository. We use Jenkins to fire off deployments and do all the transactional stuff that needs to be done on prod instances. But overall, whether we're talking about Drupal, whether we're talking about infrastructure, we should never be manually changing anything in those environments. Hotfixes are acceptable, except once you do that hotfix, you then need to get in line with the SDLC and make sure you documented why it needed to be done and where to go from there. Environment separation is also configuration management. You want to separate your prod and non-prod, and that doesn't just mean you have your database instance and you have a production database and a separate non-prod database, stage database. They really need to be in completely separate accounts. Again, we use AWS, so we should have a prod account and a stage account, and then other accounts from there. Your security logging monitoring should be isolated into our account. Any shared services in DevOps should be isolated into its own account. Now I say should for us, we actually don't do that out of the box. That's another area where we just have so much in our master account. We were able to pass the controls by putting up strict barriers between, we did have different RDS instances for our prod and non-prod. We have separate servers, EC2 servers. Everything is separated, but it is all within the same account. And we have plans that we're working on to get us separated out into those separate accounts. I'm running low on time, but if you're not on AWS, the same concepts applies depending on where you are on. Azure and GCP has their own versions of centralized AWS accounts. We officially ended 3:45. This is the first time I'm giving this session. I'm trying to see what works and what doesn't work. I'm going to keep going till 4, but if somebody needs to leave, no problems. Next up is resource classification. Everything that you create, you have to tag it. And what that looks like is this. This is one of our production servers, and you just have to define out, who owns it, what's the purpose, who's the contact, what's the classification, what environment is this, what's the data sensitivity. You need to define the different levels. That's going to be based off of your policies on who is allowed to do what with it. And it makes it easier when it comes to the auditing, because you can say, all right, I only want to see the security groups, when you're querying AWS, only show me the security groups for my production environments, only show me this for my production environments. Prod was in scope. All non-prod is out of scope for our HITRUST in SOC 2 Type 2. Encryption. Use it. This is a pretty simple one, but it can be missed sometimes. This is where we had some gaps based off of legacy stuff we had, but everything should be encrypted at rest. Databases, your S3, your EBS volumes, your backups, it all should have encryption built into it. Just use the built-in keys, AWS keys, whatever system you're using. Anytime data is moving across the line, it should be encrypted, no matter what. It doesn't really matter. Nowadays, there's no reason not to encrypt it. Document that in your encryption policy. Document how you do your key management. We use AWS key management, and they do everything for us. We just turn it on and say that's our keys, and they rotate it, and we don't have to think about it, and we inherit the controls from them. Secrets. All applications need secrets. Drupal needs to know the database credentials, and our front end needs to know the OAuth secrets and all of that jazz. You can't obviously just hard code those in your settings.php file. You can't just hard code those in your YAML config export. basically, they should never be committed to version control. You can get by manually having some a settings.local with secrets in there that are never committed in Git, but the compliance frameworks really want you to be using some form of a secret management. We use AWS Secret Manager because, again, we're in AWS land, but also, we use 1Password. All of our passwords that we share as a company are shared in different vaults in 1Password, and even there, it's not like a company-wide. The RTs don't have access to the engineering vault with our passwords there. But our COO does, and that's how she is able to get access to a Break the Glass account. Is she has access to that in 1Password when nobody else does. Well, I think she does, and our COO does. Speaking of that, our COO has some of the least amount of access to our stuff, so that's pretty funny. Short-lived secrets are preferred. You want to rotate them, you want to audit them, and make sure they're part of what gets revoked during offboarding. Backups is a huge part of compliance. You definitely need to have backups, but it's not just enough that you have the checkbox on RDS saying it's backed up. It's not just enough that your EC2 volume is being backed up, or that you dump a database backup of Drush every 5 days or whatever. You need to retain those backups for a certain period of time. So you have to have a frequency that they're done, and then they must be protected, the backups themselves. So even if somebody has access to SSH in the prod, that person doesn't necessarily need access to those production backups.
Do you also have in place, or how did you come up with a plan as well to use the backups in case you need to go recover?
Yes. We will talk about that.
You were going to get in.
We will get to that.
Okay.
Absolutely. Your backups need to be immutable. That means when they're created, they can't be changed. They can't be deleted. They can't, go away except after a certain period of time, and the system will do that. Ideally, your backups are versioned. Your retention periods are going to be defined by your policies and enforced. You need to test your restorations. We'll talk about that in a minute. And the whole process needs to be documented, monitored, and auditable. They're going to want to see your policy. They're going to want to see the screenshots of the configuration that literally says, oh yeah, we're totally doing that. They're going to see that the backups are encrypted. They're going to see the logs of your tests. What we back up is our production database, the file objects, the EC2 images, our volumes. All of our configuration infrastructure as code is backed up in GitHub. All of our encryption keys and secrets, logs that need to be backed up. And a neat one or interesting one is the critical third-party SaaS data. If you have some other system that you integrate with and you rely on that data, you can't just say, they're going to back it up for me. You need to take responsibility of that if it's important to your business. Retention policies are going to depend on your policies and what you're doing. Our prod DB backups are at 90 days. Our logs are 7 years. Our PHI is 7 years. And the evidence we provide, HITRUST is even something we need to keep backed up. The evidence of our backups we have to back up. And we have to keep that for about a year and a half. A big key thing here is, again, you have to do what your policy says. This was a gap in our coverage. We thought we were backing up everything for certain periods of time, and it turns out we weren't. We had a decent amount of backups, but not to the level we were supposed to. So we had to scramble to get all that enabled. AWS Vault is a great tool to help you configure all of that. We already talked about that. An important part of backups is RPO versus RTO. In the event of a loss of the system where you need to use a backup, You need to define how much data loss is acceptable to you. Are you willing to lose an hour's worth of data, a day's worth of data? You know, some sites it really doesn't matter. For an e-commerce site, for a healthcare site, an hour's worth of data is a lot of data. That's a lot of expensive data. So that needs to be defined. And then RTO is how fast do we need to be recovered in time from the point it goes offline to when we know we need that backup. We really can't go past this point in time. Is that an hour, 4 hours, a day? It really just depends on what you're doing, but that needs to be a part of your policy, and then you need to work to do that policy. When it comes to restoring those backups, if you don't test restoring your backups, then you don't have backups. So what you need to test is fully restoring the database environments. You don't need to obviously restore over your production, but you need to restore it to a PHI approved environment that you have documented as secure, so that you can then say, yep, there it is, and blow it up a second later. You need to do point in time restorations to say, at this point in time is where we really need to target. There was a problem, we need to recover from there. You need to be able to do individual records restorations. That's something that we have had to do in the past, where a customer of ours, if they're getting audited and they say we need the records of these 5 patients from 2003 to 2004, I'm not going to have that readily available in our active database. So I'll have to pull up an old database, restore it, and then we run some scripts on it to pull out those records, and we dump those to PDFs and deliver them, and then shut down the old instance. So that's something we have done before. And then you need to test that you can actually meet those RPO and RTO timeframes that you have defined. The frequency of these tests, at least do it annually. It really just depends on how big your system is. That those RPO and RTO factors, if those are small numbers, then you want to be testing that more often. If they're large numbers, then you can test them less often. If you have big changes, that's big infrastructure changes, that's a great opportunity to test those. Incident response. Let's say something does happen. God forbid. Knock on wood. We've never had an incident. There we go. What's going on? You got to document your incident response. Make sure everybody knows the roles and responsibilities. Big ones are going to be disaster recovery, kind of like what we've been talking about. And the other big one is going to be a business. On here. Sorry, guys. How about this? That's going to keep going. I'm just going to keep talking from here. During the most important thing. Figure out what's going on, fix it, find one person's going to be in charge. That could be something that rotates, depending on a call schedule. Everything that happens during that incident, just log it as you're going, and preserve that evidence. A big key thing is, don't arbitrarily just reboot servers or wipe logs. You want to be able to preserve that stuff, because you may need that after the incident to see, okay, what actually went wrong. You want to do a post-incident review as quickly as possible so everybody's memory is fresh. Come up with a root cause analysis. We're not blaming. And then if there are things that need to change, don't just say, we'll do better next time. You have to assign those action items and have proof of completion and update playbooks, run books, anything that happened. Test. Run tabletop exercises at least once a year. Make sure you have cross-team roles in there. Simulate realistic scenarios. Had a heart attack. Our CEO got hit by a bus. I am unavailable for outage. What do we do? Simulate what could happen. Using any of these big systems, you don't have to audit what they're already. You don't have to provide evidence for things that they already do. I don't need to prove that an AWS data center has secure access to their facility. They already do that. So grab their SOC 2 Type 2 report. If you're a customer of any of those, there's going to be a compliance section where you can download that stuff. And if when you're working with a partner, they're going to know what you do and don't have to keep account of. Penetration testing is going to be a big part of your compliance. You need to do it. But just like if you're going to have a cleaner come to your house, my mom would clean the house first before they came. Go ahead and run your own internal test before the professionals do it. You don't want them to say, oh, you forgot to put a header here. You can figure that stuff out yourself. Get all the low-hanging fruit done. There's a great tool, ZA Proxy or Zap Proxy, whatever it's called. That's what we use to run our own internal pen tests and resolve any issues. You absolutely have to have critical and high issues resolved. Medium and low, not so much. But if they do find a critical or high, you need to remediate it, and then that needs to be tested again. Asset inventory tracking, track it. Pretty straightforward. I have a slide on Drupal for compliance. I figured I should probably talk about Drupal stuff. You need to treat Drupal as a framework and not just a content management system. It's config management. Use config management. Everybody should probably be doing that these days. You want to minimize find a balance between custom code and contrib code. You don't need 10 contrib modules for something you can do in 10 lines of code. But at the same time, the more custom code you have, that's more of an exposure area for you. These were just a list of some modules that help with compliance, with authentication, with access control, with hardening. Security review is a great one because that calls out a number of modules of things you can do. Inputs, logging, monologue's a big one there. We're shipping our logs to our own open search now in addition to Datadog. Config and supply chain security. Some of this stuff happens in the at the CI level. If you, as part of every PR, you should be running Composer audit, and if that comes up with a issue, that should not allow that to go forward. Encryption. We have with our integrations. Our customers can enable integrations with third parties, and that means they need to be able to put their API key somewhere. So when they put that data into an entity or wherever it is, that's getting encrypted. None of that's stored plain text. On the DevOps side, PHP Stan, linters, Drupal Coder, Dependabot, all of that, especially Dependabot and even PHP Stan, if they're throwing errors, that should prevent it from going live. Because that means there's issues with the code or there's issues in your dependencies. Multi-tenant, we use groups. Drupal. All right, certification process takes a long time. The readiness process was 25 requests that we had to see if we were ready. The actual HITRUST was 348 requests of controls and evidence that we needed to provide. All of that took 18 months for us. So plan for a long journey. We were in that 18-month period. In the beginning, you prep, then you do a readiness assessment, then you start collecting evidence. There's going to be a period of 90 days where you have to operate and do everything correct. Follow your policies, make sure everything's set up correctly. Then after that, they start collecting that evidence for that period, and then they send it off to, in this case, the HITRUST organization, where they may have some questions and kick it back to us. We were right there in the middle of that. It took us 18 months. Things that are going to slow you down is everything we talked about, not being ready. Big takeaway, hire a consultant. They help out a lot. My closing is document is the thing here. Just make sure everything's documented. Integrate it into your daily workflow for what you're doing. Just keep on documenting. Understand the scope of what you're doing and document some more.